Hey everybody, it's Mrs. Cat here to do a few more stoichiometry examples with you. So we're going to look at 3 more problems with mole ratios, stoichiometry, and BCA tables. Let's check out number 1. Lead will react with hydrochloric acid to produce lead 2 chloride and hydrogen gas. How many moles of hydrochloric acid are needed to completely react with 4 moles of lead? I'm going to start by marking up this problem. I like to highlight in color code. So I'm going to highlight my reactants in yellow, and I'm going to use green to highlight my products. And then I'm going to use blue for what's given, which is our 4 moles of lead, and what we're trying to find, which is moles of hydrochloric acid needed. I'm going to start out by writing out our balanced chemical equation. So we're going to start with our lead and hydrochloric acid, which we would actually name as hydrogen chloride. Which is going to be HCl. And that's going to react to give us lead 2 chloride, so that means lead with a +2 charge. Chlorine with a -1 charge means it's going to be PbCl2, and then hydrogen gas, which is one of our 7 diatomics. So now that I've got all reactants and products written, I can balance this equation out. It's going to be pretty straightforward. All I need is a 2 in front of HCl. Now that I've got that, let's go ahead and put in our before line. So I'm going to start out with that 4.0 moles of lead. Because we don't have any information about the HCl, this is going to be our excess. Okay, and as you know from the previous video, I like to use a little line to designate the switch from reactants to products. So we don't have any products to start out with. In this reaction, we're going to have 0 moles for each of these. Okay, now we're ready to use our coefficients from the balanced equation to help us figure out how many moles we're going to have in our change. Now remember, we're always going to use up reactants, so I'm going to go ahead and start by putting a minus sign for each of those. We're going to create products, and there's our plus sign for each here. Okay, the 4 moles of lead that we have is going to be used completely up, so I'm going to go ahead and subtract that. That has a coefficient of 1, so when we look at the moles of HCl, we need to look at the coefficient of 2, and we're going to double that. So here we're going to use up 8.0 moles. Okay. Switching over to our products, both of our products have a coefficient of 1, which is the same as the lead, which tells us we're also going to use 4 moles. This time we're going to create 4 moles. Now all we need to do is evaluate. We're going to wind up with no moles of lead after. Since we don't know how much of the HCl we started with, we're just going to write that as excess. And then we're going to end with 4 moles of both the lead 2 chloride and the hydrogen gas. Okay, now that our BCA table is complete, we can look back. We're looking for how many moles of hydrochloric acid are needed. We're going to get that from our change line, which is going to be 8 moles are needed. So that's going to be our final answer, 8.0 moles of HCl needed. All right. Moving on to question 2. How many moles of hydrogen gas will be produced if 2.5 moles of calcium hydride react according to the following equation? So this time we've already got what we have for our balanced equation. We're looking for moles of hydrogen gas if 2.5 moles of calcium hydride react. So let's take a look at our before. We've got 2.5 moles of calcium hydride. Nothing about the water, so that's going to be our excess. I'm going to divide between reactants and products. no products to begin with, so that's 0 moles of each. Okay. Again, change line is where we use our coefficients from the balanced equation. So we've got 1, 2, 1, 2. We're going to use up all of the calcium hydride, so we're going to subtract the 2.5 moles since we use up reactant. Again, subtract reactants, add for the products. This time we're going to use that coefficient of 2 times the 2.5 moles of calcium hydride. That's going to give us 5.0 moles. Now with simple ratios like this, just go ahead and do the math in your head. You don't need to show any work for that. Okay, again, calcium hydroxide is our product. We're going to add that same coefficient as the calcium hydride of 1, so that's going to be 2.5 moles. And then coefficient of 2 for the hydrogen, so multiply that 2.5 by 2, gives us 5.0 moles. Okay, evaluate all the way across. Our after line, all the calcium hydride's used up. We're going to have leftover water, so we're going to write excess, and then 2.5 moles of the calcium hydroxide and 5.0 moles of hydrogen gas. Okay, that's what our question was asking us for, is how many moles of hydrogen gas. So that's going to be our final answer. I'm going to rewrite that down here. Change colors back to purple. 5.0 moles of H2. Okay, again, we're always going to work BCA tables in moles. Works out really simply when we're given moles to begin with and we're asked for moles as our final answer. If you are given grams or you're asked for a final answer in grams, make sure you're using molar mass to either convert into moles before putting into your BCA table or converting back to grams after you've finished your BCA table. Okay, last of our 3 examples. How many moles of water will be produced if go back to the highlighter here. How many moles of water will be produced if 4.5 moles of oxygen reacts according to the following equation? And we've got 2 C6H6, that's actually benzene, plus 15 oxygen yields 12 carbon dioxides and 6 waters. So not as straightforward with our coefficients here, so we're going to need to do a little bit more work to figure out our changes in these substances. So just like every other example so far, we're going to start by figuring out what to put in our before line. So here, the C6H6, benzene, is our excess. Nothing about that is given in the problem, but we are told we have 0.45 moles of oxygen. Okay, I'm going to give my little yield squiggle, 0 moles of both of our products. Okay, so change. At this point, we know we're going to use up both reactants, so I'm going to subtract moles of those, and we're going to create product, so I'm going to add moles of CO2 and H2O. Again, these coefficients and our ratios that come from them are not as straightforward as we've had so far, so we're going to need to set up proportions to solve for those. Okay, I'm going to switch colors and use my workspace down at the bottom to figure this out. So we know we're going to use up the 0.45 moles of oxygen completely. You can actually go ahead and fill out your after line there, but we don't know how much of the C6H6 we're going to use. I do know that I have 2 moles of C6H6 for every 15 moles of oxygen given as our ratio from the balanced equation. So we can use this to find out how many moles of C6H6 are going to be used if we use up 0.45 moles of oxygen. Again, standard proportion here. We're going to cross multiply and divide. So we're going to take 0.45 times 2, divide that by 15, and for x, we're going to get 0.060 moles of C6H6. Now that makes sense. Our coefficient of 2 is significantly smaller, I'm going to go ahead and put that in 0.060 moles, and then excess as our after. And moving on to our two products, same process, new coefficients. So for CO2 from the balanced equation, I've got 12 moles of CO2 that are going to be created for every 15 moles of oxygen that are consumed. And again, X moles of CO2 for every 0.45 moles of oxygen. Okay, cross multiply and divide to solve for X. So we're going to take 0.45 times 12 divided by 15. Should be larger this time. X is going to be 0.36 moles. And this is of CO2. Notice how I'm putting not just the value and the label, but I'm also putting the substance every time I write this down. Now that we are switching between reactants and products and multiple compounds or elements in a reaction, we want to keep track of not only the amounts and the units, but what we have. Okay. Last, we can go ahead and fill it out this after 0.36 moles. Okay. Lastly, looking at water, which is actually what we're looking for in our problem here, we know that we have 6 moles of water that can be produced when we use 15 moles of oxygen. We're going to look for that number of oxygen moles for every 0.45 moles of oxygen. Again, cross multiply, divide. We're going to get hopefully half as much as we had before, and we will. When we take 0.45 times 6 divided by 15 is going to give me 0.18 moles of water. Add that in to our BCA table. Add that into our after, 0.18 moles. And that is the answer that we're looking for. Whoops, change that back to my highlighter. Okay, 0.18 moles of water. Okay, again, if you were looking for mass, we would use a molar mass and a ratio to convert that into grams. Okay, hopefully you've got a good handle on some examples of stoichiometry. Now take a look at worksheet. So now take a look at worksheet 5 and try some of these on your own.